Okay, so today I want to talk about managing your front end with Webpack. About me, my name is Johannes Ewald. I work at Perigon as well. And this is the logo of Webpack. Webpack is a module bundler. So you might ask, what is a module bundler? So let's say we have two modules, Module A and Module B, and this is just a simple Node code. You just require Module B and it exports 42. Maybe you don't see it in the back. So this code, it's easy to run this code in Node, but it's very difficult to run it in a browser because the browser doesn't know about modules. So a module bundler basically just creates a bundle.js and puts it all into one file, wraps it into a function closure, and then you can send that to a browser and execute your Node code basically in a browser. So bundle.js can now be executed anywhere in any environment. So if I created a HTML file and reference it, it will log 42 in my browser console. So let's take a look at Webpack. I explained what a module bundler is. You probably know Browserify. Browserify is a module bundler as well. So what does Webpack differently? It works like this. You call Webpack entry, that's your first module where you want to start, and your output. So let's say we do Webpack a.js and output to bundle.js, and then it prints a nice console message, and then you have your bundle.js. And command line is always a bit complicated if you need a bit more options, and Webpack provides many options. So you probably want to put them in a config file, and that's easy. You just call Webpack --config, and then you can define basically the same thing, define your config. And if you call your config webpack.config.js, you can just run Webpack in the folder, and then Webpack reads the config. So let's take a look at the bundle. The bundle contains some code here, but it's not so long. I think about 30 lines. That's basically the module system, so that you can run your modules in the browser. And then here are, oops, sorry, YouTube. And then here there are our two modules. And I don't know, if you take a closer look, you see that Webpack changed this call. Here there's no Webpack require a.js. Webpack replaced our paths with IDs because we don't need this path resolution logic anymore. We can replace it by IDs and then just load the module by ID. So to sum it up, Webpack includes a small module system and file names are transformed to IDs. That's in contrast to Browserify, who does the path resolution logic, which takes much more overhead in the runtime you send to the browser. So, but not everyone is writing CommonJS. It's a pity that you have AMD as well, and probably someday ES6 modules. So there are plenty of ways to write a module in JavaScript. We have CommonJS, AMD, and ES6 modules. But the good news is that Webpack is capable of understanding all these module styles. So you don't have to be concerned that, oh, I want to use this library, but it's written in AMD shit, I can't use it. So Webpack understands the define and require module.exports. So, but that's cool, we can require our JavaScript files, but websites are more than just JavaScript. Websites are HTML, CSS, fonts, and images. So, wouldn't it be nice if we could all just require them? So let's take a look at an example. I have a view, hello-world.js, and this view has a template. It would be nice if I could just require this HTML file so I can put my templates in separate files and manage them separately. And it has a style too, and I just want to require the style here. So our hello-world.html would look like this, a div and a headline and a very easy style hot pink. That's my favorite color in CSS. But Webpack doesn't understand HTML or CSS. It's a module bundler for JavaScript. So what do we hear? That's where loaders come in. Loaders are transformations that are applied on files. They pre-process files. For instance, they can transform CoffeeScript to JavaScript. That's taken from the documentation. So let's take a look at one of the easiest loader. It's the raw loader. It takes this file content, let's say we apply it on the HTML file. It takes the HTML file and turns it into a JavaScript module that exports the content as a string. You can't see it back there, I guess. Yeah, can't change it. Sorry. Okay, and if you applied the raw loader on the CSS, it takes the file content of the CSS and turns it into a JavaScript string, and then you can work with that string. So how do we actually apply them? First of all, we need to install the loaders via npm. That's very easy. Npm install raw loader, save, and then if we use the inline style, it's separated with an exclamation mark. So you write raw exclamation mark hello world.html, and actually this syntax isn't made up from by Webpack, but it's actually proposed in the common.js specification, but not very well known, and I don't know if anyone knows the specification actually. Yeah, that's how you write it inline, but you don't always want to write it in your requires, so most of the time you define your loaders in your Webpack config. This is via config. You say define a regular expression here. I say when the file is ending on .html or .css, I want to apply the raw loader. And then I can just write require hello world.html. I don't have to do the raw exclamation mark thing. So now I can require HTML and CSS, but what's about fonts and images? Well, if we take a look at our CSS, CSS provides a syntax for referencing required files. You see the URL, it's basically just like require, or we have an import. That's when we say we need another file. So that's one way in CSS to define dependencies, and so does HTML. You can say image source equals and then your file you want to reference, And that's basically just a require. So what we need is that Webpack does understand the HTML and CSS syntax. So we just install the loaders, npm install HTML loader, CSS loader, and we apply them in our config. That the HTML loader is applied on .html, the CSS loader is applied on .css. And if we do that, we will end up with that. So that's an error. What happened? Let's take a look. We have here the main entry file, hello world.js, view.js, that's all our JavaScript logic. Then we have hello world.html. And then we see two referenced files. Here we see alamedlogo.svg. That's our image we wanted to include. And here, that's our web font we wanted to include. And basically, Webpack says, module parse failed. You may need an appropriate loader to handle this file type. So Webpack tries to read the image file or the font file, and it doesn't understand it, so it throws an error. That's a good thing, because we wanted to include that file, but Webpack doesn't know how to handle that file. So then that's the question, how to handle assets that don't need to be interpreted further. And there's a file loader for that. You say npm install file loader, and you apply it in your config. Say that all files that are just static assets like JPEG, GIF, PNG, SVG, WAV, and so on. And you say, I want to load that with our file loader. And then Webpack is happy and generates the bundle. So, but what happened to those images? We can't just put binary stuff in our JavaScript. What does the bundle look like now? So if we take a look at our bundle folder, we have our bundle.js. That's basically all our JavaScript, HTML, and CSS. And we have two additional files, our WAV and SVG. And they have long, nice cryptic names. That's good, because Webpack hashed them. Then we can cache them. So that's our bundle folder is a folder that that's ready to deploy anywhere. But
so are there many images put into one?
No.
We have an image map there?
No. You probably could implement it as a loader, but in our simple example, if you had more files, there would be more files.
Okay.
So this one is just our SVG, but with a cryptic name, with a hashed file name. So let's take a look at our bundle. Here we have our module system. Okay, hello world, nice. Okay, now it's getting interesting. So that's our HTML file we required, and now I want to see what happened to the image. And if we scroll there, Webpack just ends the HTML string and inserts a regular require. That's where we referenced our image file. And the same, if you take a look here, the same happened to the CSS as well, where our URL parenthesis was, now the require is. So, whoops. What are these modules? I see here module 6 and module 5. Now we need to find them. They're here. Ah, that's easy. So our modules, our images, just turned to a simple module which exports the path to the file. So here it's preceded by a public path. If you want to put your stuff all under assets or images or whatever, that's where Webpack prepends the path, and then after that our hashed file names are. So that's why we can now insert this HTML in our DOM, and the browser requests the file and displays the file, and everyone is happy. But what if we wanted to use less instead of CSS? I don't know if anyone is doing any CSS anymore. You probably use less or Sass. So if what if our code looked like this? That's a very simple less file. We define a color, hot pink, and then here we have nested styles. That's not possible in CSS. I don't know why, because it's very, very useful. So if we wanted to use less, it's very easy. You just have to write npm install less loader. You see, there's a loader for everything. And you probably would try to do this, to say all files which end on .less should be processed by the less loader. But then if you did that, you'll end up with an error. So what happened to this? He says, module parse failed, you may need an appropriate loader to handle this file type. So our less loader seems not to be appropriate for Webpack. That's because the less loader generated CSS, not JavaScript. That's a good thing, because we need to chain both loaders. That's why we can use features of the CSS loader in conjunction with our less loader. And chaining is very easy. You just write, similar to piping things, you just write CSS exclamation mark less, and you read it like first do less, then put it to CSS, to the CSS loader. So here inline is the same. You just write CSS exclamation mark less exclamation mark, and then the module you want to require. And talking about chaining loaders, you should always chain style and CSS loader. You may ask, why do I need another loader for the CSS loader? The style loader is very useful, because if we take a look at the bundle which was generated, yes. So Webpack included another module. You don't know it. It comes from the style loader. And if you scroll down, here you see that the style loader is actually taking the CSS string and append it to the document. So here is our CSS code written, coming in as a JavaScript string, and he creates a style element and hangs it into the DOM. So if you wrote style exclamation mark CSS exclamation mark, Webpack actually attaches the style instantly to the document. And I said there's a loader for everything. That's one incredible thing about Webpack. There are many loaders. You can start using them now. So you have a JSON loader, a script loader, file loader, worker, bundle loader, coffee redux, JSON 5, ES6, LiveScript, HTML, HTML, handlebars, Dust, Reactive, EJS, YAML, style, CSS, Sass, stylus, rework, mocker, cover.js, JSHint, injectable transform, I don't know many of them too, but it probably works well with your current workflow. But what happens if my code base has more than 1,000 modules? In this case, you have a bundle.js that could easily be greater than 1 megabyte, and you know the time to display your web page should be as slow as possible. So the solution for that is to create split points, and Webpack can't create these split points for you. You know about your application, you need to create the split points. Creating split points is very easy. You just need to require it asynchronously. So in this case, in your main.js, let's say that's our main entry file, you write require ensure, and then the modules you need to load. And when Webpack hits that call, it requests it from the server, and when the thing is loaded, it calls the callback, and then you can work with your modules. So if we wrote that, Webpack doesn't compile just one bundle.js, it compiles 2 files, bundle.js, that's our entry file, and one.bundle.js. That's the second part we want to load. So calling require ensure loads the given modules on demand. It splits your code base into so-called chunks. One pro tip, use the bundle or promise loader, then you can write require, promise, other part, then you can proceed with your stuff. Now we can create intelligent split points to minimize the entry chunk. The entry chunk is very small, and then we can load stuff on demand if we need it. Good news for people who like good news, these chunks can be cached aggressively. So if we configure our Webpack to use hashes in our bundle names and chunk hashes, Webpack generates this. You don't need to read it in the back. Basically, that's our app here. We have 18 chunks, and it's all hashed. And the cool thing is that if one chunk changes, only the hash of that chunk changes, and the client only needs to request this particular chunk, not the whole application again. So you see, we can, when we have hashed file names, we can use long-term caching. We can say HTTP cache. We can set HTTP caching to 20 years or something. And if we do an update, our hashes change, and the client requests the new files, but not the whole application. And that's particularly cool because we can cache it using the application cache. So when we're using the application cache, the client doesn't need to download the first thing to spin up the app. We can start it offline. And that's easy by, you just need to use a plugin. It's called the App Cache plugin. And then this App Cache plugin takes the statistics coming from Webpack, and where Webpack says, okay, I've included all these files. And it generates our cache manifest. You see here all our static assets are in our cache manifest. And then the client is able to cache it all locally. Oops. There are also plenty of other useful features and plugins. We use also the Webpack dev server. It's for development. Then you don't need to rebundle it. It loads your application again in the browser. It has source maps support, which is very important because you don't want to debug your code in a large JavaScript file. You want your files as you have them in your IDE, and source maps are to do that. So you don't even recognize that it changed through Webpack. You debug your code as you wrote it. It also has a common chunk plugin. That's when you use modules, always the same modules in different chunks. Webpack takes all them, put them into a separate chunk, and then all these modules don't need to be in multiple chunks. They can be just in one chunk. We have also a Dedupe plugin for reducing duplicate modules. That's particularly important when you're using NPM, because NPM has a deep dependency structure, unlike Bower. And then you probably end up with multiple versions of underscore or something. And Webpack takes all these instances and boils them down to one module, but every dependency gets its own instance again. So it won't change your code. There's a component plugin for using component.io. That's cool because component.io introduced another syntax of requiring static assets, but Webpack is capable of reading them and including them into your bundle. There's an internationalization plugin, and one thing, a hot module replacement plugin. That's cool because you're able to replace modules while the application is running. So, for instance, when I'm developing our app, if I change the CSS, the page doesn't reload. Just the CSS is replaced. So I got instant feedback. I don't need to wait until the application is reloaded. There's a Webpack integration for common build tools like Grunt and Gulp. And you're probably asking yourself, who is using Webpack already? It's Instagram and Süddeutsche Zeitung. That's why we brought Webpack to Süddeutsche Zeitung. Yeah. The docs on webpack.github.io are still work in progress. The maintainer, Sokra, is working hard on them. But you can get fast support in Webpack's GitHub chat. And he has a response time of 2 hours or something. And yeah, I don't know how he manages it. Yeah. Thank you for listening.